Kelly here, and from Arctic AI. Happy to introduce him and give him an opportunity to give us an understanding of AI and how it's used in the real world. Thank you very much for attending. And the BCS with the Child Institute for IT. I'm not sure do we have the video to show?
Not
sure. Okay.
Good afternoon.
We're going to run a little quick video. So what I'll do is I'll pass over to Colin. Thank you very much, everyone, for attending.
Everyone, thank you. And first of all, thank you to BCS Toronto chapters, as well as RCMI for hosting. It's been a pleasure to organize or help to organize this event at BCS. It's a great organization, and just in the brief networking, it sounds like a really eclectic people that have been invited. It's also the event, first time I'm not able to walk around calming my nerves and expressing myself over world hand gestures. I think hopefully this can be as interactive as possible. We do have about 20 minutes afterwards for Q&A. I'm hoping that we pitch things at a level that appeals to everybody, but of course in doing so there will be some things that we have to kind of summarize a little, so please do use Q&A to ask something more complex if you're involved in the technical side, or ask me to go back to something a little bit more higher level so that I can pitch things in the right way. What we're going to talk about is artificial intelligence broadly, slightly more specifically applied artificial intelligence, which we'll define in a moment. We're going to take as our cue ChatGPT, which positively for our industry and our business has really attracted a lot of attention, has hooked a lot of people, it has brought AI a little further into the mainstream, and we're pretty excited by some of the conversations we're already having that have been prompted by ChatGPT. I'm mainly going to use that as a kind of launch pad for explaining what AI is, whether we should even use that term, and how it's going to be deployed in enterprises. I figured that this audience would be most interested in, yeah, okay, but so what, as a kind of question. So we've spent some time on some very applied features of launching AI capability in an enterprise. It won't be applicable to every organization, but again, we'll think of what the key takeaways are. Okay, so first of all, a few people have asked me who we work for and the history of our business. The question I want to start with is whether it's Arctic or Arctic AI. And the reason I'm starting there is that we've changed our mind on this about a month and a half ago, because we have realized that as AI comes into the mainstream, what naturally happens, things that have been a little bit kind of faddish in the past, is that terms are used way ahead of them being properly understood. And artificial intelligence is one. I'm sure blockchain is another. There's a lot of, let's say, funds 2 years ago investing in AI, and therefore a lot of firms who are putting themselves in AI without really being so. And then there are people who get interested in the space without understanding, let's say, the science behind it and misuse the term. And that's completely fine and completely natural. But the term AI has become, I won't say meaningless yet, but it has become so broad and so differently used that we've essentially decided, as a lot of AI companies have, to effectively stop using the term. So our website, arcticai.co, will almost certainly change. Our branding throughout this presentation, you'll see we rarely use the term AI. Now, the reason for that is that AI as a space is really about the mathematics that underpins it. And throughout this presentation, I'll keep coming back to a phrase, it's not magic, it's math. What that means is that we are not talking about something that is far beyond the realms of current statistical methodologies. We're not talking about something that requires an understanding beyond an understanding of advanced computational math, which is something that is very difficult to understand, but it is not a technique or methodology that we have not theoretically understood for quite some time. I'll keep coming back to that theme, but that's one of the reasons why Arctic and Arctic AI, for us, pretty key we get that right. and the whole industry, you'll notice, starts using different terminology to describe itself. Very quick word about us. I'm very, very keen not to be in sell mode here, but naturally enough, if anyone's interested in what we do from that point of view, I won't say no to that conversation. But very quickly, Arctic is a business that has a global clientele, or at least North American EMEA clientele. We have our headquarters here in Toronto. We used to be part of a business called Filament AI. We were a business of 3 divisions, and recently myself and some members of the management team took over our division, rebranded it Arctic AI, and have fully dedicated to ourselves. So actually the same strategy of our division before, but the time had come for us to develop independently. I'm happy to talk through anything about Arctic AI perhaps after in the networking part 2. But those are our locations where our clients are and where our team is located. Typically, and this actually will be helpful just thinking about AI as a journey, but our client journey tends to start with what is AI? Why should I not use it? What does it stand for? What does ChatGPT mean? Situations like this where we might come in and do this kind of conversation to, let's say, a group of personnel from a single organization. We can do everything from that through to building out the architecture for what machine learning, how it actually performs, training models, building software, power those models, and then the ongoing services after it. That, I say that not just to be salesy, but actually to say that that is the journey that most users of AI and enterprise will go on. It is not typically about buying into one vendor or buying one solution that does the thing you need it to do. It is a consultancy project, and the reason for that is that, as I'll come to explain, AI is something that works best when you think of it as training a person. You don't train a person to do 100 tasks, which you can do maybe not one, but certainly a handful of them, and they become specialists in that area. AI is very like that. Even ChatGPT is like that. Hopefully, by the end of this talk, gain a bit of an understanding of why that is, and maybe even an understanding of how that might actually go into your business or fit into the existing. Cool. So ChatGPT. Chat's very obvious, but GPT, even to be honest, as at a roundtable last week, people in my industry actually couldn't answer this question. I immediately came back and made sure to tell my team to be able to understand it, and not only understand it, but to explain each of the words. GPT stands for Generative Retrained Transformer, and these words are there are very technical definitions, and there are also some simpler to understand definitions. I'm going to pitch it there for the purposes of just this, but more than happy if anyone does have a machine learning, data science, or any technical background to go into this in a little bit more detail. So generative, as a keyword in modern AI, generative, as the word, same word in English means in plain English, it generates content on its own. ChatGPT, developed by an organization called OpenAI, that also recently released DALL-E, which is very worth checking out if you are involved in the visual arts or visual creation in any way. I know there's at least one architect in the room, and there's a lot of digital agencies we speak to who are interested in this from a creative standpoint. DALL-E is like the chat version of, the visual generative version of ChatGPT, which can respond with generated text. DALL-E can respond with generated pictures. So one example might be, and one I just used with aforementioned architect, you could say, show me an A-frame in the Swedish design style in spoken, which is my life ambition, I'm sure many other people's life ambition. It will produce that image, not a Google image search or even an intelligent search of pre-canned images. It will generate that image. There's some really amusing examples. I've seen Doc driving Ferrari on an Alpine highway, produced in their thousands of different variations in that theme, and extremely dangerous ones. I'm sure everyone's mind immediately leapt to the danger of asking it to produce, a politician producing this. Let's say in a certain situation that would be embarrassed by, real. That is one of the reasons why OpenAI has been very careful about who gets access to these things, and also why Google closed with keyword ethics today. Generative AI is extraordinarily dangerous as well as extraordinarily powerful, and that needs to be focused on. ChatGPT is basically that with text. So it generates on the basis of a prompt. ChatGPT is in fact a fine-tuned version of ChatGPT 5, or GPT 3.5, which is a model that can generate text on the basis of a prompt. ChatGPT is that essentially that model fine-tuned for the purposes of answering questions on the basis of a specific corpus. That corpus is the internet, by the entire internet up to, I think, November 20. Again, same roundtable last week, we weren't sure exactly what data was, so we asked ChatGPT and it told us. It's trained on the internet up to that date, and of course, will continue to evolve. So, which segues into pre-train. What does that mean? ChatGPT, GPT in general, trained in two ways, which I'm going to explain. These are really types of learning within machine learning: supervised and reinforcement. I am going to come back to these. Both of them involve humans. Both of them involve vast corpus of data and huge amount of work on the part of the human researchers to do human work in both supervised and reinforcement learning. Those who've heard those phrases will know what I'm referring to. Those who aren't sure what those mean, we're coming to that very soon. But pre-trained means that that's what the P stands for. Transformer, even more technical, so I will keep this survey, but essentially a transformer is, anyone who knows what a neural network is, you know that it's essentially trying sequentially different data options, one after the other. That is immensely fast, but is not computationally possible. It's incredibly cumbersome to train a model, and therefore very cumbersome to retrain it often enough that it doesn't learn incorrectly due to being transformer models and process all inputs immediately and underpin most NLP, which is not the same as selecting whether something's happening or not, but it's a much more kind of heavily contextual. And best example of that is Google's new translate function, if you've used it the last 3 years. But like I say, I think it might be something that in Q&A I can go into a little bit of detail. It is a fascinating but linguistic process of analysis, but for now, that's what TV means. So it generates on the basis of a pre-trained model, and the kind of model it is. That's what GPT is. So, what do we mean by learning, or in other words, what's the L mean in ML? This industry loves acronyms, so I can spend the whole evening going through all of them. But ML is the one we all know, machine learning. The L stands for obviously kind of learning, which makes this different from most other forms of computational mathematics. Supervised learning is when the human takes a training set and marks what happened at each point in that training set. A certain data point fits into. So that's mathematically, if you were to be shown an image of a strain, not to use the cat example, which is the example that everyone in our industry uses, but I will, in one of those situations where I can't think of any other noun, but another and more interesting type might be, how do we classify a painting here as of, let's say, a person, or of that as a, let's say, a piece of weaponry or something that we see elsewhere. So what we do is we take a training set, about 1,000 images of each will do, and we classify them, and we train a model on that data set. And we show it a new data point, which will be one of those two things, and it will be, if it's that simple, extraordinarily accurate at putting the new data point, so kind of painting number 2001, into one of the two categories we've showed. Clearly, there's more than two categories in life. There's many more complex, harder to distinguish things, but that learned on the basis of an annotated data set. And the word annotation and the process of annotation is a big part of what we have to do to build machine learning models. Unsupervised learning is when you effectively do the opposite. You show it 2,000, those same 2,000 paintings, let's say, although this would be too easy to ask to need this, but it's not to elucidate the same example. So you show it 2,000 paintings, and it finds that there are two very highly related within themselves clusters. There are the pictures of old men, pictures of old weapons. And the reason it's unsupervised is the human says, you tell me what pattern to find in this, which is highly useful if you don't know what the patterns are. Again, that example is way too simplistic, but if you can imagine a data set of trillions, petabytes of data, you're trying to find a pattern of data which prompts us or leads to or is somehow related in the data to a data point that you're fascinated by understanding better. Let's say something failing in our factory, machine or something of that nature. You show it data, and there may well be a pattern, which may well be somebody being on shift at that time, or weather pattern outside, or some other combination of factors with what's coming into the facility and what's coming out of it. Unsupervised learning is useful because the model gets exceptionally good at finding the patterns without being told what the patterns are, just to mature the data set. Reinforcement learning, definitely illustrated with a carrot and a stick, but it is just that. It is you create an agent or agency where you determine the outcome that you're interested in promoting in either a live process or an historical data set, which might be what is the best way, the most effective way, most effective time for this green light in the cityscape to change. And that will be a constantly evolving, almost like playing a game itself, to promote that outcome among the myriad different combinations of data logic which feed into that outcome. Now, we said that supervised learning and reinforcement learning used for ChatGPT. How? Well, supervised learning, humans annotated data from, as I said, the internet, but also from usage of GPT, and indeed are continuing to do so as we all use ChatGPT, and annotating it for topics, for quality in some cases. They're also monitoring the AI's responses and annotating that. What they're trying to do is, what is a sensible follow to this prompt? This is all started with, what is the likely next word? And if you've used Gmail or indeed Outlook now, and indeed most keywords and apps, it will suggest the likely next word, not just a typo, but the next word. That comes from what is the likeliest next word. And it's not just, I remember when you said this sentence, although those are heavily quoted in the data set. It's on the balance of where we think, what the AI thinks is, that fits the pattern of the rest of the sentence. Here is the likeliest next word. That starts with annotating the data set, annotating not just for the right and wrong, but for type of word, type of syntactical structure, for type of context. The reinforcement learning in ChatGPT was actually done with something called human-assisted reinforcement learning. So that's when a human actually plays the role of agent in both cases. So find the most effective way, the cleanest and most succinct paragraph to write, or find, because we can do thumbs up and thumbs down outcomes, the most positive or the likely most positive outcome from your response. Human assistance is often used in reinforcement learning with natural language processing, because there's so many more different things that word can be categories it can fall into, not least language, or tone of language, or sense of grammatical structure, versus when you try to get it to predict our paintings, that the outcomes are so much more limited, even in a vast data set. The outcome, there's near limitless number of possibilities with natural language processing. I'm using that term, natural language processing, because it is one text area of machine learning. Computer vision is another, structured time series data is another. Computer vision is exactly that, recognizing the paintings, and time series is like a time-stamped historical data set, heavily structured, which might be the sensor readings from our factory. But we're going to focus now on not necessarily ChatGPT, and I'm certainly not going to read through this slide word for word, but I am just going to talk to the fact that we may have those three types of machine learning, which, to be honest, don't need to be thought of as text, images, and structured data, but more just use cases where there's different levels of complexity. Underpinning them all are these paradigms of machine learning, and underpinning those are statistical techniques. And as I said, the magic crossed out, this is math, and the reason for that is that all of these techniques depend on usually one of these, or not always, there are more, But these are the general buckets where our statistical techniques come from. We hire a lot out of math, and so do a lot of AI companies. And there's a lot of mathematicians who study machine learning even at undergraduate level. Because what they're doing, if anyone's working in banking or need anything to do with heavily statistical and data, they will know what regression is. They may well have performed it in Excel on stock prices and so on. This is highly intensive, multidimensional, computational statistics, but it is still regression. Classification is a process of essentially putting one of those statistical patterns, so a number in the data set, into category A or category B. And that is how supervised learning typically works. It's painting type A or painting type B. That classification happens on a statistical data set that is still numbers. Now you might be wondering, how does a picture become a number that I can classify in an Excel spreadsheet using regression type techniques, or statistical type techniques, I should say. Well, how that works is we first vectorize that image. A vector is points plotted on a chart. There might be a billion points in the painting behind me, but there are still points. And that vectorization turns that painting into a massive Excel spreadsheet, which is not an Excel spreadsheet, of course, but just for the example, it is still a spreadsheet. And therefore, if you have the world's most powerful computer, then you can perform statistical analysis. The same goes for text. We can turn words themselves into basically points on a statistical map called a vector. And once we've done so, we're actually performing exactly the same word. Is this spam? Is this not? Is this a swear word? Is this not? That's a classification exercise on numbers. Those numbers are in a vector of those words. And so we're talking about turning entities into vectors in the way that you imagine when you drop a pin, it turns into coordinates which you never see, but it still uses coordinates, sends them to the other person's phone, which then converts them back into mapping software. So it's about turning things into numbers and then running math. And clustering, which I described for unsupervised learning, a very similar thing. What you're talking about there is you might have rows and columns. You want to determine, okay, which of these columns are related to each other over this billion row spreadsheet. There might be a billion columns too. I'm aware of my name being Colin, and at this point, one of you can make that joke. It's pretty 6 long years of it, but there might be a billion rows and a billion columns. And those will relate to each other, sometimes in very obvious ways. Because some of them might be data points like age or voting intention or buying propensity, whatever it happens to be, or price. Some of them may not. And the ones where it's not obvious is where we employ what I describe as learning, where we say, show me what the clusters are. And suddenly in your customer data set, it emerges that actually the buying propensity of similarly aged males in Toronto is not a category that we should market to. It's actually those with, let's say, similar academic backgrounds, or those who bought something else the day before that we're going to recommend to that cluster. So you immediately see that Netflix recommendation algorithms, Amazon recommendation algorithms, and even very advanced predictive algorithms for buyer behavior, the likes of kind of Visa and MasterCard are in place. Where you're not just saying, you don't want to be surprised that all of these people in this cluster who didn't existed are going to behave in a certain way. Dimension reduction, again, this is not an exhaustive list here, but dimension reduction is, you're thinking about this vast spreadsheet. Some of those columns and rows are actually not related to each other. So you can run very similar algorithms to reduce the numbers of dimensions that you're analyzing. And that can be crucial because, as we'll talk about in a moment, the computational intensity of describing is very, very high. So when we get to the point where we can train more effectively, more cleanly, more often, so that we can retrain, then that's useful. Launching an AI capability in the enterprise essentially takes all of this theory and thinks about how it is wise to develop a strategy for answering this sort of question. Who cares about these techniques? Well, right now, everybody, all of us should, from an ethical standpoint. Many people care about it for nefarious reasons, but many people, more prosaically, want to make working day less onerous, or they want to make working day focus on tasks that only you as a human. Unfortunately, there's a lot of leaders who are also thinking we do this same task with 10% fewer people, and that's certainly for us and certainly for me personally a big part of the ethics of this industry, the kind of socio-political dimension of automation. And I'm almost certain that will be one of the first 3 questions in terms of who's going to be ultimately out to pay this technology. But the first thing I want to focus on is I'm going to end on that and want to make sure we don't miss it. But the first thing to note is that this technology is extraordinarily expensive. Powering ChatGPT is starting to be reported, but is astonishingly energy consumptive exercise. I think it's something along the lines of the consumption of LA from an total energy perspective. Something along those lines. It's basically impossible to put into the work from just a cost perspective if you look at financial energy consumption metrics. That's not to say we won't improve that. It's like I say, transformer models and dimension reduction and all those kinds of things make it efficient. But it is astonishingly computational intensive. The AI revolution started really with cryptography, the second one. That was when the math was cracked for heavily computational statistical methods for finding patterns in data. In the 50s and 60s, even the same people sometimes, in the case of like Turing and so on, developed algorithms that were probably theoretically possible that are still in use today, particularly in classification. Advanced regression, regression, you take it a step further, you start to get pretty quickly into what we now know as machine learning. What changed was cloud computing and data. So those obviously work hand in hand, but cloud computing allowed us to access, in our phones, we accessed some of the world's most powerful supercomputers, if not the most. These are obviously located in server farms, guzzling electricity, so not perfect. However, we have democratized access to power and put it in one place such that it is computationally capable of performing a lot of these mathematical tasks. And there's been a massive increase, if not exponential increase, in storage and data, largely due to cloud computing, but also activities online, activities where we try to beat it harder, not the machine that runs it over, but actually goes back to the network somewhere. These are the kinds of data points that are now being stored. So I just want to flag that there's actually nothing, again, nothing magic about this. It is enormously expensive and enormously difficult challenge to think, okay, well, how do we bring this to life in practice? Again, not going to dwell a lot, again, not wanting to be too kind of tactical and salesy, but basically you need to think of this project as effectively an IT project. Maybe not one where you have the same RFP, select vendor, deploy process. It needs to start with, well, what are we going to do about AI as a technology? The first stage is not to say, okay, let's get everyone ChatGPT and see what happens. The first stage is not even to say, let's buy a bunch of AI through various vendors and let's create a system where our employees can use something else. The goal is to say, what is my role, or what are the roles that I'm in charge of or that I run the budget for, and speak to reflect the audience, and say, how do I use the technology? And the way to do that is to think of it as almost like, I'll keep going back to the architecture example, sorry for pulling that out of the tent, but it is much more like building a house rather than buying in lots of off-the-shelf software. You need to think about it as, what do we need? Do we need 25 bedrooms, or do we need 3? Do we care about having a big yard? Do we care about having two-car garage? It's basically that. It's saying, how do we deploy as effectively as possible into our enterprise? It starts by saying, let's limit our focus here. Let's be super focused on what this to achieve. The most important element of doing so is what we call MLOps. The industries call MLOps, and what that means is you need to start thinking about a chain of AI as it fits into an existing IT landscape. Right now, in the current state, this is not optimal. I'm going to present an even more time-tested slide in a moment, which is what we consider as an industry to be optimal and where it's going. But you need to start thinking about this as a process and one that needs to be set up to interact with an existing data set. So right now we have companies who are doing things like take an offline data source, dropped in some examples which are real life, but just to connect to the simplest one, we might have a situation where we're the highway agency and we want to see if somebody throws litter out because we want to do that automatically through cameras. Project we scoped to actually do UK Highways Agency in about 2017. But if we wanted to do that, how do we do it? Well, we take the data offline data source. Then we run a ton of machine learning model development. We do the tagging. And what are we tagging? We're tagging stills, trying to train the model, find me that classification of picture from video, but it's just stills from the video, which is somebody throwing litter on the side of the highway. Not actually that difficult if you can get the data, which I'll come back to. But essentially, you can train that model. You put that trained model into some kind of repo for models that can be connected, served to the service that you want, where you want that to sit. Which is probably, the model says I'm 78% confident that that car with this number plate just threw garbage on the highway. What does that do? Probably integrates with some kind of alert to the highway patrol service. As you can see, that that chain, okay, that theory, the pictures, I can see how that gets integrated, and that's kind of how it works now. The problem with that is, well, there's a lot of problems with that methodology. And as you're thinking about that example, I've really just told you that's another example of the theory that was in section 1 to explain ChatGPT. The point is more to think, well, how does that actually fit into the real world? And yes, certainly not going to go through each box or even to ask it to read. The point is, but very much more circular and very much more analytical at every step. So the key area, I think, is instead of just servicing or serving that prediction to whatever is the integration you want for them, you need to make sure, because this model is going to consistently retrain itself. If you, for example, say a human gets in the loop at the very end and says that's actually not garbage, that's just someone waving to the next car or something, or their hands out the window, the model will retrain itself. It can retrain itself in ways that you don't want. So in this example, you might see that there's a massive overpreponderance of the data of images incorrectly classified as garbage, which are not, in fact, correctly classified. The model will start to perform very, very poorly because its training set is constantly evolving. So of course, we want to put something away. Now in the ChatGPT example, this is how in previous incarnations of this kind of technology, some of the responses it was giving out started to get extremely offensive, extremely illegal in some cases, and very dangerous in terms of having been let loose. Microsoft released one on Twitter about 4 years ago, which was trained on the corpus of other tweets, and was within 2 hours saying Twitter got banned from Twitter and exploded by Microsoft because what was happening. What it's doing there is using a model that will predict what is the next word that should be. Well, what should be to a model is just what statistically most likely word after you are. And on Twitter, that's probably not going to be any good. So if you imagine that terrible example and put it into an enterprise context, you can see how making sure that you spot when that happens is one thing, that we do have a spot stage here for kind of constant analysis of output and a dashboard monitoring system, but also making sure that model retraining doesn't happen automatically. ChatGPT is putting in place things that say, when you start asking me questions on, let's say, extreme political views, it will stop the retraining process. That's the kind of thing we're talking about with a easy to understand, very dangerous example. But in your enterprise, or if you're thinking, even if you're in a junior role, even you can say, well, what should I propose to my manager for how we should use AI? But one of the things you're going to want to think about is you cannot let this loose on the world or on your job if you don't have a way of making sure that you can steer it all the time. There's a bunch of other very kind of IT-heavy components to the ideal MLOps situation in the enterprise, which is more interesting to this room than any other. There's source code repositories, there's model evaluation, kind of sandboxes, a package for testing, and of course some kind of pipeline management wherein it can, if necessary, be taken down and worked on in modular fashion without whatever service it is serving essentially becoming more functional. Lots of questions I'm sure will come from this audience or afterwards on that point, but that's what we mean by MLOps. It's simply understood as gates between services, but for an IT audience, I'm sure there's some practical infrastructure related topics to discuss on top of that. Okay, so key takeaways before I stop for questions. I do have an appendix here which has examples if you need some use cases that we work on, and I can flick to those. But the key takeaways, data, I'm sure you've already realized, is absolutely everything. This ChatGPT may have been trained on the entire internet to the experiment of 2021. Probably not a resort that anybody wants to work out how their AWS environment hosts, or less so how their on-premise infrastructure will host that. Because we want to be to develop proprietary AI in most cases, stuff that's going to give us an advantage. You focus first on where is my unique data set, and bear in mind that the unique data set has to be cleaned up, it has to be annotated, it has to be worked on to make sure that all those faults and all those gaps you might see, and I'm sure anyone who's worked in IT or works in IT right now will know that data is rarely clean and complete. We've done projects where we've used ML to complete data sets so that they're going to be built on top of it. That's the kind of data architecture, data infrastructure that's probably 90% of building an ML model is just working with the data on top of that. Bear in mind that data can be the annotation. So just imagine that if we go back to my example with paintings, imagine one's a Rubens and one's a Rembrandt. If anyone knows the differences, I'd say to expose my knowledge, but that's probably quite, or at least an example of someone who knows what we're talking about in that field. That's probably quite a difficult thing to tell. It's probably quite difficult to tell the difference between those two things. So that annotation of our 1,000 examples is pretty easy if it's all military dudes and guns, we could all do that, but not if it's, well, who's the artist behind this, or if it's people, or if it's very niche levels of knowledge about our investment classes that we're interested in, or decision by a CEO as it relates to a Latin share price. Annotation is the most valuable part of data that we're going to train on. And so you definitely don't want to be in a situation where that data goes outside the firm. There's anyone who doesn't deserve to have that data, because that data is really your intellectual capital stored in a database alongside the data set. Generic rarely works. Basically, ChatGPT is funny, interesting, incredible technology, and probably not something you want doing the kids' homework yet. It's not something you want writing your emails yet, probably. It gets things wrong in very lucid ways right now, makes stuff up often, and is trained on a data set where I don't know what the percentage is, so 100% of it is truthful, but it is certainly a very faulty one. Generic kind of works in a very similar way. Not always, but a model that predicts stock price movement may be one thing, but a model that predicts what you as an investment fund with a certain investment rationale wants to do with that information will not be generic, even from desk to desk within that organization. So generic very rarely works, very often reduces performance. You do not want, in the highway example, to show all pictures of people throwing garbage. You specifically want a data set that is people throwing garbage out of the car. Be a situation where we're finding defects in a metal part. We have 12 cameras taking a picture of the same metal part, well, you know what I mean, the same part going through in the thousands per year. The 12 cameras ended up needing their own model, because even though it was the same defect in the same part, taken from 12 angles, the model trained on the 12 images of a given part as it goes through the system was not good enough at finding defects. So each one needs its own machine learning model, not the same one applied to each image. So think about that when it comes to thinking about how, you know, actually your job can help in your industry. And then, yeah, just want to close on what I think is super important for us all to think about. I mean, ChatGPT is easy to exemplify here, but you know, to my mind, it's something that we wrestle with a lot is, in that example of the parts inspection, that job is still, as they test, being done by humans. It's not a particularly high-skill task, so it's not being done by well-paid educated humans. And those people, if the work works, will end up unemployed. And there's no point us pretending that is not the case. As the firm who built it for the company, or for the company who brings that solution decided to execute it. I think that's a dimension that sometimes is missed. The awful Twitter chatbot is at the very end of the awful end of the scale. And what ChatGPT or DALL-E, which is just to remind you of visual equipment, could do, is for sure at the absolute bottom end of the moral score scale. But the ramifications of doing what we do, or the firm automating tasks on people, and therefore on politics and on economics, and what that means for us as a society, is itself an ethical question. And how fast we do that is something that, like I say, it exercises with us. It's pretty easy to see how there are communities in parts of the world who aren't yet ready to be the steering hand on AI that a very well qualified investment professional could be. So they might deploy to make their menial tasks as well, not their task anymore, get AI to do that. But there are people who are not yet at that level. And so worst leave behind of all time could transpire if we aren't careful. And these are the kinds of socio-political and socio-economic questions that I certainly want to leave everyone with, because I think it can get a little easy to just focus on the much worse, but maybe easier to understand. Cool. I'm going to pause there for questions. I do hope it's useful. If it wasn't, feel free to ask a question later. Yeah, I'll go straight to that. I don't know if I handed the mic.
I don't need a mic, but I don't know. My voice is quite loud, anyways. So, Colin, thanks for speaking tonight. I'm the cause of you coming this evening. And I'm a fellow of the BCS, so welcome to today's BCS session. But I'm also a member of the Worshipful Company of Information Technologists Spiritual and Ethical Development Panel. So, all spirituality and ethics of AI, and I'm actually applying on an AI development tool banks here. And so one of the issues, of course, in AI and certainly machine learning, model development, and you touched upon it on the third square. On the third square, you touched
Yeah,
no,
we
it's
can-
not.
No, it's not on.
Yeah. It's nice. But anyway, the question really comes in the spirit, and you didn't really touch upon the bias, the cognitive bias. And I've seen talks about AI and decolonization, AI and male bias, male bias in AI. I don't really buy it personally, but that is the zeitgeist of today, right? So when you talk about monitoring bias, right? How does art take? What's the methodology of monitoring this? And what is the industry's perspective on this?
I think those are three different things. I think the industry is being a little kind of flippant about this. Every AI conference usually opens with the kind of ethical dimension, and that sounds like a very, very good thing, but it's often saying the same thing. And to be honest, I think the industry is starting to do a disservice to it a little bit, because it is absolutely without question that left to its own device, AI will become biased in a way that we feel is negative. It's probably too broad a statement, but in most industry applications. Our perspective as Arctic is that we do not and never want to have an AI that does something that we have, that we sell. We are focusing on a niche of saying, if you want to adapt ChatGPT to your needs, we can do that, but it will be a lot of adaptation, and it's probably more useful to build your own natural language processing tool that use ChatGPT extremely carefully. That's not anything against that technology. Wonderful for our industry, it's fascinating mathematically. But our focus is to say it's really on generic usually fails, and you need to be extremely strategic, extremely focused on what you want to achieve. And so that doesn't absolve us, but as consultants and strategists, we are not in the business of selling a thing. We're in the business of creating a great outcome for our clients. Now, that great outcome, we will hopefully continue to work with clients to include in that great outcome, not completely removing the need for a workforce, not doing something that is unethical from a buyer's perspective. And our advice will include that. And there will be moments when we say we're not willing to work with you. If we feel that our brains, which is basically what we sell our time, our abilities, our experience, are not used in a fashion that we can. Again, we just launched the Arctic Foundation, which is where we are going to put our clients among charities, all of whom have been heavily discounted so far. We're not yet in a position to do it for free, but we're passionate about doing so. We have initiatives for diversity and inclusion across a team and across groups. A big part of what we want to do with the foundation is to make sure that we say, frankly, bluntly, that we are building things that result in job losses and may result in biases. So what are we going to do about it? We want to be front and center of that today. My perspective is that there are biases that are unfortunately mathematically accurate on the basis of historical data. So there are groups that are underrepresented, which means if you have to predict likelihood to be a CEO for pilot resumes, now the math isn't quite as simple, but you just had to predict from pilot resumes based on historical CEOs what gender select that mathematically is the most likely to be a CEO material, then you would pick them. Because if you're thinking very mathematically about this, the historical data set is massively skewed. I'm going to reveal a little of my politics, which words in that career, but I believe strongly in intervening in that mathematical certainty to say this underrepresentation is unfair. And the mathematical model, and unfortunately a lot of people in the industry say, what do you mean fair? It's a machine. No, it's making a mathematical judgment that you've trained it to do. And that judgment, if you've trained it to make that judgment on that simplistic basis, now if anyone did that, it would be never do that. But oversimplifying for explanation, in that situation, that should absolutely not be taking the human element of where we want to go as a society out. So that's my perspective. Too early.
Well, you hit all three. That's good.
Yeah, go ahead.
So I have a question. Basis when you are engaged by an organisation, just on the ethics side, how much do they bring in, say, a governance structure and things, sort of oversight for solution, like operation risk management, but with this
Yeah, great question. And look, to be honest, we've worked with a few massive enterprises, but mainly we're working with teams that don't have that kind of structure. So, for example, we do tons of work with venture capital funds, investment teams. We don't tend to come across a situation that is, where there's a team looking into ethical dimensions. We have had a lot of situations with big corporates where they are dealing with enough data and they're dealing with people usually in their end product where that has an issue. And typically what happens is that it goes to legal still nowadays, rather than something ethical. A good example is a big real estate firm who I would name, we're not familiar with this public purpose here, but it's a we are allowed to talk about it, but it's a major Toronto realtor who had a computer vision deployment in a different facility through a different firm that went very badly wrong from a PR perspective. Storing data They didn't do anything wrong with it, and they did a wonderful thing, which was immediately close down all AI projects and figure out what is our thinking to safeguard this data. Wasn't so good for our revenue that year, but it's a great thing to do. As they said, oh, just realized how dangerous this could be. This was 2018. So that's the kind of thing that still hasn't quite left legal or PR, but you can see how very quickly if you deploy this everywhere, you get in a lot of situations like that where a framework would be useful and so on. Again, we're hoping to become pretty good at helping design that framework and operating models for ethics and AIs and stuff like that, but we're just not coming across mature enough organization yet. From a government's perspective and IT perspective, I not that I can't think about it. Every firm is asking this question, so how secure is this data? The IP considerations are really interesting. Data, annotations, an AI model, and then the AI algorithm, or the retrain model that you might use to customize it into a new model. There's just 4 different parts of IP, and we like the client to earn as much as possible with that. The governance perspective, IT governance perspective, that's super interesting, and particularly if they have their own environment that they will support the data.
Yeah, I can see where, it's right, there's follow this bias.
Yeah, that's again, large enterprises for sure have that. Work with Athens Health Group, charity in Canada, and they had a huge process pipeline into the data that they have. We're keeping an eye on everything they do and everything the data team does. But it does take it takes an organization of a certain size to have that structure in place. The operational risk of something being put into an IT structure breaking for sure we have to go through, but no more than any other vendor. Yeah.
It's a great presentation, thank you. I just wanted to find out, because I know AI and I guess GPT has been around for a bit now. I guess like 5 years or a little bit more. So why has it become in the forefront like the past year or two?
So I've been in the field since 2014, and saying that again, but it was at the time, the limitations were quality of data in some fields, but to be honest, the limitation of the business I had then was more about take up in the general public. So what started the AI revolution, which basically was kicked off in Toronto by Jeff, who leads the Vector Institute, which kind of god within the industry, was in the let's say 2000s, and then things started like spam filters were in this case, basically good spam filters, searching for keywords. There were lots of use cases that people didn't realize were machine learning. But what's really changed in the last year, to answer your question, is things like DALL-E, ChatGPT, the realization that your people's own jobs could be automated, or at least these could be hugely advantageous part of your life. I mean, my favorite example of this is, okay, we've had typo predictions for a while, we've had Grammarly for a while in our emails, we've had next word suggestion in our emails, and then we have sometimes, at some point along that spectrum, I think, wait, I wasn't needed for any of that except what you said. Now I see why this is so material. And then I think there's a lot of like viral and social media as well that take. Now, I don't know if everyone would agree with that take, that basically nothing technological. It's not that nothing technological has changed. There's huge advancements like ChatGPT or GPT or the new Google Translate service that I mentioned. But to me, it's more like, to be honest, we're getting a ton of interest from people who would never even look at an AI pitch because of ChatGPT. And nothing in our pitch or technology or industry or capabilities has really changed. I think that's an indication of the fact that really what's happening is that it's advanced, as an industry, we're advanced to the level where it's immediately obvious to most people in the world where this could impact their lives. Yeah.
I have a sensible question and a probably ridiculous question. So I'll start with the sensible one first. Looking at the industry itself, given what happened with blockchain, which was the most recent technology, which promised a lot, but really turned out to be maybe 10% useful and 90% BS, and I'm probably being generous there. Are you concerned that this industry is going to get swamped by the equivalent of crypto bros, I guess it would be, where the industry starts getting swamped with dubious projects that start drowning out the good quality work? And my second question is, how close do you think we are to HAL 9000 in 2001: A Space Odyssey?
Yeah, neither of those are ridiculous questions. Well, actually, I was thinking you were going to ask me to classify the sentences into one or the other afterwards. But I think to start with the, I'm going to answer that in three ways. One very quickly, and two proper answers. So to answer your second question really quickly, decades, if ever. Right. I'll come back to that. Going back to your kind of sensible question. I don't know if people know about the garden trough of disillusionment and the hype cycle. And basically, that technology gets capable and it hits this peak. And then it falls as people realize it doesn't what was expected. It's called the trough of disillusionment. And then it becomes a real technology that's useful. It's a good entrepreneurship course or business school, everything like that. Read about the sector, it's full of hype cycle. And most people think that AI is right at the top and it's about to get invaded by a load of BS and purveyors of BS, and they will hit the trough of disillusionment. People be promised an AI solution doesn't work, and then everyone will start talking about each other about how this whole thing's trash. People excited about it in 2023, but it takes until 2026 for the industry to provide valuable use cases. I disagree with that. I think we're at the end of the we're coming out of the trough of disillusionment in certain spaces within AI, especially chat and conversational AI and implementations into enterprises. In some parts of AI, we are very at the start of that curve, particularly as regards artificial general intelligence. It's a very famous CEO who I would name, I'm not a huge fan of, but he is a peddler of a lot of stuff that won't happen, and that will probably form its own website. But I think if you take the industry as a whole, enterprise use cases for AI, I've spent 9 years variously trying to, and pretty reasonably successful, talking to enterprises about this. And about 3 or 4 years ago, the no was, we tried it already, it's crap. We set up Borealis, and those scientists don't ever come and speak to us about helping us make decisions. Or we bought layer 6, RBC this TV, and we haven't seen a ton of value. That's nobody's fault. It's largely because everyone saw theory, saw the potential for business transformation, and didn't do anything about it. And that's what MLOps is, and that's what enterprise AI is, applied AI is. Now we're seeing people go, actually I was on the phone to a massive E fund in Montreal today, it's just clients. They had $8 million under management, speaking to the CIO. They say ChatGPT is the most used tool in the organization. They are seeing, oh, cool, do a slide deck. We're doing projects for PE firms who just want 300 million documents from the data room in the investment process to be converted into a summary slide so that the humans don't have to read and type in the PowerPoint. So you can see, and darkening is very targeted use cases are emerging. So I think I haven't answered your question, but I think I was adjacent to it. But I think that we've already had the bros, we've already had the stake oil, we've already had our crypto moments. What happens when that happens is valueless stuff. Old crypto in Europe. Opinion I would imagine, I'd probably share it, but the what's left behind, and I would put blockchain in this, things like legal and banking and stuff, is left behind to emerge into the proper industry. I think we've had that. We've had, hey, I've got an AI that spots people throwing garbage out of the car on the highway. All I need is all your data, and I'll sell it to you. You don't have anything, and you just have a mathematical model written in paper somewhere. But that business was probably getting funded to Series B 2 or 3 years ago. So I think we're seeing we're emerging from the BS trough, let me say it like that. And that's a positive look on it, to answer your question. Slightly longer, but not particularly long answer to your question. I think we're miles away because I think people are misunderstanding what kind of general intelligence is. And AI is really terrible at what it is. It's terrible at analysis. It's terrible, and when I say analysis, I mean not just producing data onto a deal sheet, but saying, should we buy this number? It's terrible at meeting people and saying, hey, trust me with your money. It's terrible at understanding how urgent something is in Scrum, or figuring out whether somebody needs a little bit of help when telling do a Scrum. Those are not things that I believe everyone is. I think the most important kind of intelligence is, even in product design and development, is one of empathy, where you develop a product for people to like it, and develop a great product and great code for that to have, or for success to be achieved. I can't see anything requiring actual intelligence as defined in that way being automated in. Probably, yeah. And I have a lot of other comments on that as regards what humans like to do most in their lives, and whether they want to live in a world that are completely automated. I have a generally pretty positive view of GI as it relates to the universe. But yeah, again, Jason, to your question. Yeah, go ahead.
Speaking about different approaches.
Sure, there's actually a multi-day office. It's one we're building up. It started out actually as a relationship with a subcontractor. We found a place that has immense development talent and great regime to work with, and was a little bit lower cost to live on that much. And we will let that office, and we have let that. So sure. So I think there's generally within a project you have to, there's a Scrum methodology, there's a methodology that needs to be followed, but generally speaking, that works pretty well. The office is open to the client, which tends to be for us just for now in the US, as well as your client in London, hopefully not knowing soon in Geneva, but mainly it's US and Toronto. We get close to the client and obey what they follow the culture within that organization. So if they're super fast, quick, they work like that. If they're super enterprise grade, but slower moving, we can work with that. So it's less about geographies for us, about the client. I think there was one more, sorry.
So my question is about, like, when you mentioned the working, like that's also classified sometimes, like there's something, or like there, when you talk about vectors in a spreadsheet, like how can you process and classify human evolvement?
You effectively can't, but what you could do, and some firms try to do this, and some pretty successfully, is queue up a kind of like, think of like a decision tree for different, let's say, facial movements. So if someone says this word, this volume in this way, you can do classifiers of those things. Say tone is this. And if I can say something that sounds angry, but with a smile and in a certain tone, and you go to like your ears, that's it. And that's quite human emotional cues and sensitive context. Sometimes we might get that wrong and misunderstand each other. So humans aren't always perfect. But what you can get AI to do is say, okay, I recognize a smile. I understand these words are classified as critical. But the context is something else. And you can then set up a logic tree that says, in those circumstances, this is the tone of the thing, it's text. And that's actually a lot of the time how firms who are analyzing interviews with AI, firms that are doing sometimes mental health counseling sessions, overlaying AI to guide the answer. But it's a really interesting field. It's important to note though that even if we do get to the point where there's a client on model, which I don't think is very far away, the machine is still not feeling that emotion. They're just classifying what other humans have told it are that emotion. You only need to move on your own from London to Toronto to Berlin, and there are different classifications. So, sorry, step and many social puzzle if you don't get that right. But that's the kind of thing that, like, the feel is of course important part of that. So the human is never going to be able to feel anything. Sorry, the robot is never going to be able to feel, but it might well classify certain patterns over time. And yeah, that is a field that's pretty much a solved problem. Is I think just struggling for data.
So we appreciate the time for one last question.
My question is around medical applications. I just wondered if you've had any experience, or if you haven't, like where you could see like AI.
Yeah, absolutely. We have quite a few actually. I'll start with an area where we haven't done work, but has been worked on a lot by other firms, and that is recognition of images. I'm afraid I don't have the terminology. If you work in the medical field, you use it. Well, the kind of X-rays and the cell analysis. I think I know the word, but I'm not going to get it wrong. So essentially, images of a cancerous cell or cancerous cell or those kinds of things. It's very much a solved problem in the sense that there are lots of great use cases where, in actual fact, the judgment of is this cell cancerous is the machine, I'm afraid, is far outpacing the judgment of high-level hospital consultants in judging it from images. Now, the hospital consultant would say, no, you're fine. Hospital they go to other tests. Rarely do we miss as humans, particularly if there are advanced stages. But the machine basically does this from data points. The things that's something I'm very passionate about, because humans sometimes do get it wrong. That we're doing a project right now to spot lung cancer from basically respiratory data. It's a field that hasn't really been cracked because there hasn't been much medicine that says that some of this data is actually predictive of lung cancer. But the CEO of our client wrote a PhD on actually there are some data to certain countries where this is an earlier predictor than, let's say, doing a cell analysis at the right time when by definition you already have cancer. So super interesting project that for us is a perfect example of how all that kind of boring mathematical theory gets into a really useful use case. What that is predictive statistical analysis of just vast amounts of medical data from machines. There's other great use cases we've done: physician research, physician interviews, and overlaying AI to detect patterns of emerging pathologies. We've seen a lot of computer vision on skin kind of defects and so on to predict things like melanoma for certain spot or other. There's wonderful use cases. Whenever a human's looking at an image or massive amounts of data to make a prediction, the prediction being, is this person sick with something or not? Typically, that data is highly repetitive. That's machine does that. So yeah, lots of use cases that we're doing.
So the great news is lots of questions. There's opportunities for more questions over the further. So there's an opportunity medically adjacent, which is the insurance now. But we would like to thank you.